Now that we have the two components of velocity, axial and radial velocity, pressure and temperature, four variables at each cell center, let's post-process the results. And this is usually the most exciting part of the whole exercise because you get these nice, pretty pictures that can help you develop physical intuition. If I go back to the project page, I will right-click on results and say edit, and that's the post-processor. Now I have Fluent open, so Fluent is using up the single license that all these applications share. So I'll say, hey, request license. So now the license has been transferred to the post processor, which is called CFD post. And if I zoom in here, and I can do this using the right mouse button, similar to the mesher, and I can look at all the entities that have come in. If I look at periodic 1, that's our flow domain. So what, the 2D geometries come in as 3D geometries. It three-dimensionalizes 2D geometries because the post-processor essentially works in 3 dimensions. But we can ignore that three-dimensionalization and just plot everything over periodic 1. And we can look along periodic 1 by saying, Z. Okay, so we look at contours along periodic 1. And let's plot the velocity vectors. So I'll go in here and I'll say vector, and I'll leave the default name. And like I mentioned, the location is periodic 1. And let me say apply. And if I zoom in here, okay, the symbol sizes are too large, so I'll go to symbol, and I was playing around with this 0.05. Seems to work well. Okay, and if I click on this, I can translate the model, and I can also keep zooming in, and actually we can also reflect it about the axis. That I do under default transform. So double click on default transform, unclick instancing info from domain, and say apply reflection. And we want to reflect about the ZX plane in Fluent notation, and say apply. So that's like a cross section through the pipe, and now I can see how the uniform velocity profile, is evolving into the expected parabolic profile. So you can see the velocity profile is still evolving, and somewhere down the line you are beginning to see fully developed flow. And all these are coming from the cell center values based on interpolation. Okay, and you can play around with if I go back to vector 1, there are lots of options here that you can play around with. I'll let you explore. You might also want to put the legend, make it horizontal. So I can double click on legend, and I can say appearance. Let's see, actually definition, horizontal, and appearance. I will say, give me 2 decimal points. So I'll say fixed, and you can see the effect of that. So that's a much nicer view of the color bar, and the maximum velocity is around 0.2, and that's expected because in fully developed pipe flow, the velocity at the axial velocity at the center becomes twice the average velocity, and in our case the average velocity was 0.1, so 0.2 is exactly what we would expect. So that shows you how you can visualize the velocity vectors, and I'll save the project. And I will say request license.